Hi guys, it's Ms. Griffin. We're looking at Unit 6, Skill 1. Okay, so yesterday, or however long ago, in class, we did a little bit of work with polynomial functions and figuring out, is it a cubic, is it a quadratic, is it a quartic, what type of polynomial is it, and how many roots could it potentially have, and where does the graph actually go? Does it point up, does it point down, does it point in opposite directions? So we're going to do a little bit of reading and a little bit more discovery on that right now. So it says complete the reading below, highlight and annotate any important information you find. So you should be making sure that you are marking up your reading as much as possible. So you're going to pause the video, you're going to read through it until you see the part where we have to actually start taking notes together. But then I'm going to go back through the reading and highlight some important piece of information and just kind of recap what you learned, and then we're going to fill out this little summary section of your notes on the last page of this skill. Okay, so pause the video now, start reading, highlighting, annotating. Annotate means write words. Okay, so anything that you feel is important to write down to help you to understand this a little bit better. Okay, so as I was reading, I noticed that the end behavior of a graph, you can see my highlighted portions here, are when the graph goes to infinity or negative infinity on x. So you guys have learned about this back in skill 2.5. So like as we go to the right, the graph goes up, right? This is going upwards. And as we move to the left, the graph is going up. As we move to the right, the graph is going down. As we move to the left, the graph is going down. Now they don't always have to match. You have to see that here in this picture. So oh, this is annoying. I don't know why it does this sometimes. I'm sorry. So as I look at these pictures, if I have a positive leading coefficient, that will change the way that this graph looks. So it says the degree and the leading coefficient determine the end behavior. The sign of the leading coefficient is sufficient to predict the end behavior. And then another piece of information that I decided to outline or highlight was that when you have an even degree polynomial, so that's the top 4 boxes, you'll notice that it's either up on both ends or down on both ends, depending on whether you have a positive or negative leading coefficient. So if it's a positive coefficient, your graph's going to go upwards. If it's a negative coefficient, your graph's going to point downwards. And we kind of talked about that a little bit when we were doing the quadratics unit back in Unit 5. Now, if we have an odd degree polynomial, such as something to the 3rd power, 5th power, so on and so forth, they might start down and then go upwards. So they start down but end up going upwards. That's if they have a positive leading coefficient. If they start up and go downwards, so something like this one, they start as going to positive infinity on the left, but then they end up going downwards on the right-hand side, then they have a negative polynomial. All even degree polynomials behave like quadratics on their ends. So all even behave like x squareds. And all odd behave on their ends like linears, so x's, or cubics, x to the 3rds. Flip it over and we'll take a look at what I highlighted as important information on the next page. So in this problem, it was a little multiple choice question. It said, which of the following represents the polynomial whose leading term is negative 3x to the 4th? So you first want to be looking at that x to the 4th, and it says that it's an even degree, right? 4 is an even power. And so therefore, your ends will match. So that should get rid of 2 choices for you right away at least. So that gets rid of choice C because my ends go in opposite directions, and choice A, again, because the ends go in opposite directions. Now we have to decide based on the leading coefficient, that negative 3 that's in front, whether the ends point upwards or point downwards. So it's a negative coefficient, which means that the ends go down. So essentially it's this graph, but it might have more loops to it because it's a higher power, a higher degree, which means that we should be choosing choice B here. And that is all explained in the paragraph below, where it says the important things to consider are blah, blah, blah. So you can read through that one more time if you are struggling to understand why we chose choice B. In this next part, it said to describe the end behavior when we have this function. So we don't even have a graph. We don't want to try to fiddle with the window to try to make it look right on our paper, or on our calculator rather. We just need to look at the leading coefficient and the power. So this is an odd degree, meaning that the ends go in opposite directions. So remember that for odds, the ends go in opposite directions. For evens, the ends always match. So we're going to have either a graph that goes like this or a graph that goes like this. And the way that we can find this out is by looking at the coefficient. So this is a positive 3. Therefore, when we have a positive, it's going to go in the upwards direction overall, meaning it starts down on the left but goes up on the right. So we looked a little bit at zeros, roots, and x-intercepts the other day. They all mean the same thing, so you have to understand that these words are interchangeable. And there's this fundamental theorem of algebra that says that a polynomial of nth degree, so it could be like the second degree or third degree, x to the third, x to the fourth, of n degree can have at most n distinct roots, right? Makes sense. X squared can have at most 2 roots. And they're real roots that we're talking about here, so the ones that cross the x-axis. Or x to the 5th can have a maximum of 5 real roots. Right? You see that nth degree matches the nth number of roots. So we're looking at these real roots, and again, that means where we cross the x-axis for this polynomial here. And it says that it's got a third degree because that's the biggest exponent, degree of 3. So now we're looking and we're like, okay, well, it crosses once, it crosses twice, and it crosses 3 times. So each of these are roots. -1 is a root, 0 is a root, and 1/2 is a root, because every time we plug it into the function, it gives us 0 as a result, which is another reason why it's called a 0. So a degree of 3 has 3 real roots at most. Having at most roots doesn't mean that it's actually going to cross the axis that many times. So having at most n roots is no guarantee that it will actually cross the x-axis that number of times allowed. For example, this one here is still a third degree, so it's a max of 3 real roots, but it only crosses 1 time, so it only has 1 real root. So you need to understand that functions, polynomials, can have a maximum, but they also have a minimum. So an even degree polynomial can have from 0 to n distinct real roots, 0 being the minimum, it doesn't have to cross at all, and n being the maximum. So you can see that if I have a quadratic, it could cross 0 times, it could cross 1 time, meaning touches the axis, or it could cross 2 times. And again, they could be positive or negative coefficients pointing it upwards or downwards. So even degrees can cross 0 to n times. An odd degree, on the other hand, has to always cross at least once. So the minimum is 1, the maximum is n, and you can see this example right here. It has to cross at least once, it could cross twice, or it could cross 3 times as we saw up above. So now we're going to flip over one more time to kind of just summarize everything that we've learned in this reading. So up top it says that we've got these different graphs of different degrees. So just so you can see what they look like, it says the degree of a polynomial is determined by the highest exponent on a variable. So for example, of a degree 5, this would be x to the 5th power, somewhere in the equation. And then degree 4 would have to have x to the 4th, so on and so forth, counting all the way down, x squared. And then this one would just be x or x to the 1st. Same things. So when we're looking at this little chart to kind of summarize, we're going to look at degree, the leading coefficient, whether it's positive or negative, a sketch of it, and then its end behavior. So if we have an odd degree, that means it might be like x to the third, or it could even be x to the first, x to the fifth, x to the seventh, so on and so forth. When we talk about even degrees, that would be something like x squared, x to the fourth, x to the sixth, x to the eighth, anything to an even power. When you have a positive coefficient on your odd power, so we're going to start sketching this first one, you're going to see that the graph overall goes upwards. So in the end, it ends up going upwards towards the sky, and on the left side it points downwards. On the other hand, for a negative coefficient for an odd, we know that the graph starts in the sky but goes downwards in the end. And it could have more curves in there overall, like it might look something like this, but as long as it starts in the upper left and ends in the bottom right, that means it's a negative coefficient. So as we talk about the end behavior, we notice that for an odd, the ends are opposites. So you know that as we go to the left on a positive coefficient, we are going to negative infinity. Again, that's because we're going left, and then the graph is going downwards. As we move to the right, it's going up to positive infinity. This is what I mean about the ends are opposite, right? So the function goes in opposite directions. Then when we talk about the negative coefficient, as x goes to negative infinity, meaning towards the left, our graph is going upwards to positive infinity. As we move to the right, to positive infinity on x, the graph is going down to negative infinity. And again, you can see clearly that the ends are opposites. One's positive, one's negative. Now, if we take a look at graphing a positive on an x squared or an x to the fourth or x to the whatever even power, we know that it's going to have the ends pointing upwards. Or if we look at a negative coefficient, the ends will point downwards. And so now I recognize that on an even degreed polynomial, the ends match. So as x goes to to negative infinity on the positive degreed polynomial, we know that as we move left, we are moving up, so positive infinity. Because the ends match, the same thing should happen as I move to the right. And as I move left, this graph is going downwards for a negative coefficient, so negative infinity. As I move right, it's going downwards again, so this should be negative infinity as well, because again, the ends have to match. And then one more thing here to talk about is the zeros. So when we have zeros on a graph, this is the number of times the graph crosses the x-axis. And remember that another way to mention zeros are real roots, real solutions, or x-intercepts, right? So those words are all interchangeable. And if we have an even degree polynomial, it has a minimum of 0 roots, real roots, I should say, and a maximum of n. So again, n is the degree. Maybe we should write that. N equals degree of polynomial. And for an odd degreed polynomial, it has a minimum of 1. Remember, it has to cross the x-axis at least once, but it can cross it as many times as the degree allows. So if it's a 5th degree, it can cross it 5 times. All right, let us know if you have questions. Go back to your reading if you have any questions first. Look at the summary chart and try some of those practice problems before you take your CFU. It's very important that you practice these pieces of information before moving on to the CFU.